Let us talk about how our ancestors started sailing across the seas and oceans in medieval times. If you want to sail across the ocean nowadays, you'd pull out a phone. A satellite would show your location with a very high accuracy. A lot of technologies are available to give you directions. But none of this existed for thousands of years. It was just open water in every direction, and sailors had to entirely depend on their human expertise, with no guidance from any kind of instrument. And yet people were able to sail across the oceans. They found tiny islands in the middle of the largest ocean on the planet, thousands of years before anyone had a way to document their journeys. This is not a story about one voyage. It is a story that stretches back further than our own species, and it raises a question that still doesn't have a clear answer. How do you sail across the great oceans, toward lands that you have no proof they even exists, while using nothing but a raft or manually constructed boats? To get at that, we have to step back to 1 million years before Homo sapiens existed. In 1998, archaeologists working on the Indonesian island of Flores found some simple stone tools that was cut from volcanic rock. Later digs at a site called Voyages pushed the dates back further, to roughly 1 million years old. Flores has been an island for millions of years, separated from the nearest mainland by a deep water channel that never closed, even during ice ages when sea levels dropped. Whoever made those tools wasn't Homo sapiens. Our species did not exist yet. The most likely candidate is Homo erectus, a hominin with a brain roughly 2/3 the size of ours. And somehow, a population of them ended up on an island that a land bridge could never have connected to anywhere else. This island sits right on the edge of a boundary geographers call the Wallace Line, named after the naturalist Alfred Russel Wallace, who noticed in the 1850s that the animals on one side of this stretch of Indonesia looked completely different from the animals on the other side. Tigers and elephants are on one side, marsupials and giant lizards are on the other side. Even at the lowest sea levels of the last ice age, deep ocean trenches kept these two regions apart. That means anything that crossed it had to sail through an open sea, a large expanse of water with strong waves that never once went away. So how did Homo erectus end up on the far side of that line? How were they able to sail across the ocean? There are two competing explanations, and researchers still haven't agreed on which one is more likely. A tsunami or a major storm can rip up a chunk of coastal forest and carry it into the sea as a floating island. This is called accidental rafting. Animals living on it get a free and unplanned voyage across the ocean. Such scenario has actually been documented in modern times, most famously after a 1995 hurricane carried some green iguanas over 300 kilometers from Guadeloupe to a new island in the Caribbean, where a breeding population still lives today. It could also be that this was not an accident at all. Maybe the hominins were already building simple rafts on purpose and paddling across short stretches of visible land. Flores is part of a chain of islands, and from many points on one island, you can actually see the next one on a clear day. In the early 1990s, an archaeologist named Robert Bednarik decided to test this directly. He built rafts using only tools and materials that would have been available 1 million years ago. His team paddled the bamboo rafts across stretches of the strait separating these islands, following the currents that would have existed in the past. The rafts held together. The crossings worked. This is not a sure proof that Homo erectus definitely did this on purpose, but it shows the idea isn't far-fetched. Same raft that was built by the research team could have also been built during the Stone Age, whether or not they set out to sea intentionally. Whatever the answer may be, one fact will remain true. Long before modern humans existed, a hominin species had already sailed across open ocean and survived on the other side. Now fast forward past the rise of Homo sapiens, past the slow spread of our species out of Africa, to a crossing that almost everyone agrees was deliberate. Around 65,000 years ago, give or take a few thousand years, depending on which dating method you trust, humans reached the landmass archaeologists call Sahel. At the time, sea levels were much lower than today, so Australia, New Guinea, and Tasmania were joined into one continent. The site that anchors this date is Majidbeb, a rock shelter in Australia's Northern Territory. This is where researchers found stone tools, ground ochre, and grinding stones buried in soil layers dated using a technique called optically stimulated luminescence, which measures when quartz grains were last exposed to sunlight. At the lowest ice age sea levels, Sahel was never connected to the Asian mainland. To get there, people had to sail through a scattered chain of islands now called Wallacea, which includes Timor, Flores, and dozens of smaller islands. Even if you took the shortest possible route, researchers estimate that the final leg required crossing at least 70 to 100 kilometers of open water, with no land visible on the other side during the early part of the trip. This is a different situation from Flores. It couldn't have been one lucky raft that was accidentally carried by a storm. Reaching Sahel required a whole sequence of crossings, and the boats had to be good enough to carry not just individuals, but enough people to start a population that survived and grew. Some researchers have modeled this by using computer simulations of ocean currents and estimated crossing times. They did several tests to confirm if a group could realistically drift there by accident. The simulations mostly come back the same way. A single accidental crossing might be possible, but a sustained population arriving and thriving on the other side strongly suggests people were doing this on purpose, and they did it more than once. Somewhere in that chain of islands, people built boats capable of carrying families, food, and fresh water across open ocean, without knowing for certain that land was waiting for them on the other side. We do not have any of those actual boats. Wooden structures normally rot away within decades, so nothing survives from 65,000 years ago. Everything we know about how they might have done it comes from indirect evidence, the tools they left behind, computer models of ancient currents, and experiments like Bednarek's rafts, built later to test whether the physics of the idea even holds up. What we can say is that this was the earliest known deliberate sea voyage in the history of our species, and it happened tens of thousands of years before anyone invented the wheel. For a long stretch of history after that, sea travel mostly hugged coastlines. People sailed along the edges of continents, from island to visible island, rarely losing sight of land for long. The real leap that produced the boldest ocean crossings in human history came much later, and it was out in the Pacific. Starting around 3,000 years ago, a group of related cultures known as the Lapita people began spreading east, out of the Bismarck archipelago, near modern-day Papua New Guinea. Over the following centuries, their descendants pushed further and deeper into the open Pacific. They settled in Fiji, then in Tonga and Samoa, and eventually in all the vast scattered islands of what we now call Polynesia. The distances involved here are on a different scale than anything before. Hawaii sits roughly 3,800 kilometers from the nearest inhabited islands to its south. Rapa Nui, also known as Easter Island, is one of the most isolated inhabited places on Earth, over 2,000 kilometers from its nearest populated neighbor. New Zealand sits alone in the Southern Ocean, far from anywhere else. But people reached all of them, likely reaching Hawaii and Rapa Nui sometime between 900 and 1200 CE, and New Zealand a bit after that, by around 1300 CE. None of this sailings happened with the help of instruments. There was no compass, no sextant, and no written chart. What existed back then was a body of knowledge that was been passed down from person to person, refined over generations, and held almost entirely in individual memories. The starting point was the sky. Polynesian navigators memorized what is sometimes called a star compass, a mental map of the horizon divided into houses, each one marked by where a particular star or constellation rises or sets. A steady star near the horizon at night could be tracked for hours to hold a course. And as one star climbed too high to judge accurately, the next star in that same house would take over, handing off the bearing like a relay. During the day, when the stars weren't available, navigators read the swells. Ocean swells are different from the choppy waves whipped up by local wind. Swells are long, regular patterns generated by distant, steady weather systems, and they travel for thousands of kilometers in a mostly consistent direction. An experienced navigator could lie in the hull of a canoe and feel the rhythm of the swell through the boat itself, using it to hold a bearing even through a cloudy night with no visible stars at all. Birds mattered as much. Certain seabirds, especially terns and noddies, fly out from land in the morning to fish and return to it every evening. Spotting one of these birds late in the day and noting which direction it flew could point a navigator toward land that was still far below the horizon. Cloud formations offered another clue. Islands, especially ones with lagoons, often produce a faint greenish tint on the underside of clouds sitting above them, a reflection off the shallow water, visible from many kilometers out before any land appears. Drifting seaweed, patches of floating debris, and the direction of prevailing winds all added to the picture. None of these signs worked perfectly on their own. What made the system work was combining dozens of small, imperfect clues into a single mental picture that got checked and corrected constantly throughout the voyage. In the Marshall Islands, a separate tradition developed a physical version of this knowledge. Navigators built stick charts out of thin strips of palm rib, tied together with small shells marking island positions. They were teaching tools, used on land to help a navigator memorize the way swells bend and interact around a chain of islands, the same way a swell pattern would feel from inside a canoe. But these charts weren't carried on voyages. Once the pattern was learned, the chart was often left behind. Becoming a master navigator was not something that could be learned and mastered in a single season. It took years of apprenticeship under an established navigator to learn how to read the ocean under every kind of weather and light. Knowledge like this had no backup copy. It lived entirely in the memory of the people who held it, and it was only as strong as the chain of teachers passing it forward. There is also a strange thread of evidence suggesting some of these voyages went further than islands. The sweet potato, a crop that originated in South America, was already being grown across parts of Polynesia by the time Europeans arrived in the Pacific. Linguists have pointed out that the Polynesian word for it closely resembles words used for the same crop by indigenous groups in parts of South America. How the plant got there is still debated, but one plausible explanation is that Polynesian voyagers reached the coast of South America and sailed back, carrying the crop with them. After European contact, this entire tradition came close to disappearing. Colonization, disease, and the introduction of European ships and compasses disrupted the long chains of teaching that had kept this knowledge alive. By the middle of the 20th century, on most Polynesian islands, nobody could remember how to navigate this way anymore. One of the last people who did was a man named Piailug, a master navigator from the tiny island of Satawal in the Caroline Islands. He was trained in the old system by his grandfather. In the 1970s, a group of Hawaiian researchers and cultural revivalists built a double-hulled voyaging canoe. It was based on traditional designs. Piailug was asked to guide it on a voyage from Hawaii to Tahiti, using nothing but the methods he learned as a boy. In 1976, he did it with no instruments, just the stars, the swells, and decades of memorized knowledge, a journey of over 3,800 kilometers across the Pacific. He went on to teach a young Hawaiian navigator named Nainoa Thompson, who developed his own version of the system and has since led further voyages, including a full circumnavigation of the globe using the same non-instrument methods. Because of that work, this knowledge exists today, not as an artifact in a museum, but as a living skill, still being taught and still being used. When you look back across all of this, from a hominin crossing a channel it shouldn't have been able to cross, to the Polynesian navigators memorizing the entire sky to find islands the size of a small town in the middle of an ocean that covers a third of the planet. What stands out isn't the technology. The rafts and canoes were simple. What made this possible was attention. Careful, patient, repeated observation of the sky, the water, and the birds. The knowledge was carefully passed down across generations and refined for so long that it eventually let people do something that still sounds almost unbelievable when you say it out loud. Our ancestors sailed across the oceans without the help of any instrument or technology. They did it by trusting what they had carefully learned to observe.